Hi guys, for question 2, once again we are given a bit of information. We know we've got a right angle triangle, but we don't know the y coordinate for P as yet. And so we were supposed to find that coordinate in the first question here, 2A. So what I've done, I've already drawn the diagram and I'm showing you that in my case, to make things easier for myself, I'll actually take advantage of the fact that I've got a right angle triangle. And so I will use the fact that the gradient of perpendicular lines, the product thereof, gives me a -1. So you can see I've substituted already, which I think is something that you guys can easily follow through. And if I'm to simplify here now, I've got 4/3 times 6 minus k over a -4 is equal to -1. You can see 4 takes care of the 4. And I've got a -3 that I'm going to multiply by on both sides because it's basically taking the reciprocal. Okay, I multiply by -3/1. What I do on the right, I've got to do on the left because there's an equation. So we want it balanced at all times. So I am left with 6 minus k on the left, and this is equal to 3. And you can see, if I am to substitute here, guys, in fact, I can just take k to the right-hand side and 3 to the other side, but we can all see that k is equal to 3. Now, let's see what are they saying in the next question. Determine the coordinate of S such that QPRS is a rectangle. Now, you guys, what I saw is that some of you really got confused and it did not make sense. Some things did not make sense. So what I saw people doing is that they tried to extend this thing and think of a literally serious big rectangle and all that. But guys, I want to challenge you and say, remember that a square is also a rectangle. And I have given you that video where I actually went through classification of quadrilaterals. So what what you needed to think about here, it's fine, say you did not see that. But even if you were to find the coordinates of S, you know that what is going to happen is that adjacent sides of a rectangle are at 90 degrees. So what we could have done here is to use that fact, or another fact that we could have used is that you could have used the fact that the diagonals of a triangle bisect, yes, bisect one another. So that's another way, I guess, you could have tried. But let's try this one because it seems to work quite easy. So if I look for the gradient of this line here, this is S, right? And this is now R, which we now know is 6 and 3, okay? And we know Q here is -1 and 2. So if, in fact, let's just put up all the information that we know about rectangles here. We know that opposite sides are equal and also parallel. That's what we know. Maybe I should mark this in red so that it can be clear in your vision there. So we know that the opposite sides are equal but also parallel. And this is the same thing here, right? And we know also all angles are right angles. So you see, there's quite a lot of information that you can actually use. We've spoken about diagonals that they bisect. Maybe I could throw that in also, if you like. So they bisect such that you've got sent this point as the midpoint either for this part for these lines or those lines. That's one of the things that we know, right? So you could have used this fact or that. Really, there's a lot of information. Okay, for myself, I think I already know the gradient of QP, and I think that means I already know the gradient of RS. So check this. Knowing the gradient of QP, I've erased it, and we had actually found it. Oh, yes, we had actually found that gradient, and maybe we can quickly find it. MPQ once again. That's going to be 6 minus 2 over 2 plus 1. And we can see this is 4 over 3, right? Now, I know this gradient has to be equal to the gradient of RS, which will be 3 minus y at S over 6 minus x at S. And we can see actually both coordinates are going to be positive. Now, the second equation that I have is that this gradient of PR, I can find the gradient of PR. What is the gradient of PR? The gradient of PR is 6 minus 3 over 2 minus 6. This is 3 over a negative 4, right? Which makes sense because that's the reciprocal of that. Now, I also know that this gradient has to be the same as the gradient of QS. And the gradient of QS will be 2 minus y at S over negative 1 minus x at S. Now, guys, you've got two equations. This equation 1, this is equation 2. And you can actually use these equations to find these two unknowns. So 2 unknowns, 2 equations, that is enough for you to solve this. So I'll leave it at this point for you to complete the memo and find the coordinates of S right there. Okay, then we are told in the next question that TQ is produced, maybe I shouldn't have taken that off. TQ is produced to TAN minus 6. So negative 6 is the y-intercept, and we see that is produced when what happens if PQ is produced to that. So somewhere there. So we can see if we have everything according to scale, actually, that coordinate should be a negative 7. So you can see from the sketch that you are looking for a negative 7. Find the value of A. Guys, you already know the gradient of this line is 4 over 3. So this gradient, let's just use TQ now. T is A and negative 6. So we're going to say, okay, if we are to look for the gradient of TQ, it will be negative 6 minus 2 over A plus 1. And notice I said plus 1 because that's a negative 1. So obviously the negative and negative will give me a positive. Now this is all you've got to solve for. You've got to solve for A in this, and it must give you indeed a negative 7. Then finally calculate PQR, angle actually, not just PQR, angle PQR. And I saw some of you guys did some lovely, incredible stuff. I should applaud you for that actually. What some of you did here is that they used the technique that I had shown you, and that's why I say really that was impressive. So let's see, P is 2 and 6, there's P, and Q is negative 1 and 2, right? And we know now that R is 6 and 3, so maybe I can just look for 3 on the y-intercept, and we know that R will be somewhere there. And so what guys did, which I said I found it quite impressive, and that's why we say there are many ways to kill a cat in mathematics. What folks did here is that they realized that, well, I've got a P here, and I've got a Q here, and I've got an R here. And I'm looking for this angle, right? Angle PQR. So they worked on a triangle. I saw folks working on a triangle. And what makes me say this brilliant is because people thought of out of the box, okay? So you found the length here, someone found the length, let's call that length 1, someone found the length there, and someone found the length there. And folks just named this angle, and they actually used, some I saw they used sine theta, some they used tan theta. But guys, that was really brilliant. That was really brilliant. Even if you found this length and you found that length, and you just use any a trig ratio, in this case, opposite over adjacent is 10. That was really brilliant. And that was quite impressive. And you do know that this is a right angle, right? Okay. I mean, you know it's a rectangle by now. That's what you know. So again, you could actually use the theorem of Pythagoras to find this side if it was that difficult. But I was just impressed at how folks worked here. So I gave you an idea, try and work through that also and find the angle PQR. Your answer if you are doing everything correct, guys, should actually be 45 degrees. So this angle here is actually 45 degrees. So I was quite impressed by how people actually did what we call thinking outside the box. Well done to those of you who did this. Next video, I will conclude on the third question. Cheers.